Welcome to today's Introduction to Operational Research. This is a National Cheng Kung University bridge class presented to you by me, Marvin Lee. And so in today's bridge class about operational research, what are we going to discuss about? This course consists of 4 parts. First one is the fundamental. What is operational research? And second one is real-life examples of what can I do with operational research. And the third one, we're going to lead you step by step into solving an operational research problem. And fourth one will be our conclusion. Let's start. So, what is operational research? Operational research is a method from mathematical programming. By definition, operational research, OR, as known as operations research, is an analytical method of problem solving and decision making that is useful in the management of organizations. In OR, complex real-life problems are broken down into manageable parts, analyzed using mathematical models, statistical analysis, and algorithms, and then solved to improve or optimize performance. So what kind of event or activity should we use with operational research? Why operational research is created in the first place? So there must be a practical need for operational research to exist, for it to thrive, and now we can see operational research in our life. And first, operational research is developed in the Second World War. In Second World War, there's limited resources like metals, like plastics, and all that resources have to be given to war. So in war, all manufacturers have to produce a certain amount of guns, ammunition, and tanks. But there's no enough material for every manufacturer to make every tank, ammunition, and fire gun as they wish to. So there comes operational research that they use mathematical models to estimate that how much gun, how much ammunition, and how much tank they can produce with a certain amount of limited material. So this can be a broader concept of a limited time versus manufacturing need. If you want to make a water bottle, but you only have 24 hours, and how much time does a water bottle have to take to produce? So 24 hours divided by the time it costs to produce one water bottle, and you can get the amount of water bottle you can produce in 24 hours. But the thing can become much more complicated. You have limited time, limited money, and limited resources. And you not only have to produce water bottle, but now you have to produce a basket. You have to produce all kinds of other things. So now it becomes a limited time versus multiple choice. What product you want to produce to maximize the production? What is the best arrangement for your production to use up all the resources and achieve your goals? Now we can take a deeper dive into the steps in operational research. So in operational research, this is considered as a workflow in solving a particular problem. First one, we have to define the problem. Like one of the production of water bottle problem we just mentioned, we have to define the scope, which is This problem is related to production of water bottle, and the objective is to produce as much water bottle as we can. And the constraint is that we only have this amount of time and money. And secondly, we have to move to data collection. We have to gather how much money it takes to produce one water bottle. And to ensure that this data is accurate and reliable. Because if it's not reliable, then 2 hours of time can be changed to 1 hour of time or 3 hours of time. And our final conclusion will be wrong based on the wrong data. And to identify data source and method for data collection, maybe we want to ask experts for their first-hand information, or we want to collect the data ourselves. And then the third part is the model formulation. After we have gathered enough data, we can form our mathematical model. This mathematical model have to represent the real-world system. We have to define the variable, parameters, and relationship between them. Variable may be the amount of water bottle we produce per hour, and the parameter may be the time it costs for a water bottle to be produced. And we have to formulate the objective function and constraint. The objective function is the amount of water bottle we want to produce. And the constraint is that we only have limited amount of time and money. After we have built our model, we have to do the fourth step, model validation. We have to verify that this model is accurately representing the real-world system, that the amount of water bottle we produce in our model formulation can be correctly representing the amount of water bottle we can produce in real-life manufacturing. By this, we can use historical data or case study to test this model, to test if that can really represent the real-life scenarios. And we can make adjustments to improve the model accuracy. On the fifth step, we have to generate the solution. So based on our model, we apply appropriate OR techniques to solve the model, and to generate potential solution and analyze that if they are feasible. For example, if you only have 24 hours and every water bottle took 1 hour to produce, and now it came out to be you can produce 100 water bottles. That doesn't even make sense. So in this way, 100 water bottles may not be feasible. You can only produce 24 water bottles unless you put in more resources. And in this way, we can use software tools to help us generate a solution. Some very interesting findings from the solution generation is that we have to examine the solution to check if it's really accurate. Because by different OR techniques, you can find different kind of solution. And here comes the fourth step, solution analysis. We have to evaluate the solution based on criteria such as cost, efficiency, and feasibility. If we use a method that costs much more than the money that we spend on manufacturing water bottles, then that may not be feasible, and that's not reasonable, and that's not efficient. Because we spend too much money on our model generation and solution generation. So we can choose a more cost-effective method. And we have to conduct sensitivity analysis to understand that the impact of change in parameters, such that we can understand how much time we used to produce one water bottle. And if we increase the time to 3 hours, to 5 hours, to 7 hours, and how much more water bottle can we produce more. And we have to consider trade-off between different objectives. Like we want to produce water bottles and we want to produce baskets. And the baskets and the water bottle may have conflicts. So we have to trade off between them to produce more baskets or to produce more water bottle. And then comes to the seventh step, the implementation. We have to develop an implementation plan for a chosen solution. Like we have already found that manufacturing 10 water bottles in 24 hours is feasible, and we can do so. We have to communicate the plan to the stakeholders, like the manager of the plant or the supplier of our materials. And we have to monitor and control the implementation process to ensure that this implementation process is going by our plan. And the final one is to monitoring and to review. Continuously monitor the system after implementation is very important because we have to review the performance and to compare it with the expected outcome. If the performance does not meet the expected outcome, we may have to go back to our previous step and to revise our model and to ensure that the model generates the final solution that we need, and to make adjustment to ensure the solution remain effective. And finally, throughout these steps, what expertise is related to operational research? First, the operational research focuses on mathematical and statistical expertise. We have to use a lot of numbers to represent real-world scenarios, and also analytical and computational skills. We have to use computer software to help us done the operational research optimization part. And related to this is computer science and information technology. We use computer to help us through the journey. And business and management skills. This is related to project management because a operational research optimization is really interlinked with different roles in the business field that we have to manage and have to communicate with them. Next is the domain-specific knowledge. If you are working in the medical field, you have to have a domain-specific knowledge about medicine that you can communicate with others in their field. If you are working in the educational field, you have to know how they interact with each other in educational field, and all the specific keywords and understanding of that particular field. Lastly is the interpersonal and the communication skills. Because only if you have interpersonal and communication skills, you can convey your operational research ideas to others. And other people may understand how you are going to make this more effective. So that's all of our today's bridge class. Hope you enjoy your journey in operational research and make everything more feasible, more efficient, and more cost-effective. Thank you.